Hello, everyone. Welcome to another class of pre-calculus review, and today we will be going over the concept of vectors. So, what are vectors again? Well, if you've taken physics, you've probably heard of them once or twice before. Essentially, in physics terms, a vector is a certain force in a certain direction. Now, what's important about this is that the information needs to include not just the number of the strengths of the force, but the direction as well. And this is no different in mass. In mass, vectors represent to a number tied to direction. Let's say 500, and a direction to, let's say, upwards. So effectively, this would kind of be represented as a arrow going straight up, written next to 500, showing that it is worth 500 units. Now, when we get into how we write it, it's a bit different. So, in math, vectors are not too different from x and y values. It's part of how we write them. To explain, they are kind of written in by using a and b. Now, what makes them similar is that when you write them out in notation, you kind of do it in a form similar to these coordinates. Oh, sorry about that. It appears that I was having some troubles with my mic. Can you hear me now? All right, let's see. And I need to turn up the volume. All right, back to the lesson. Now, when you first, let's take a look at an example of a graph. So, if we have an example of a vector that goes here, assuming, say, this is 2 and this is 1, and the coordinate of this point would be 1 comma 2, right? This is essentially how a vector is generally represented. Of course, the point doesn't always have to start from the origin. It can start from, say, 1, -1, 2, 1, 0. Maybe like this. The vector could look like that. However, in most cases, when we're discussing about one vector only, we generally tend to start it off from the origin. Now, when you write vectors, you generally tend to write them by express. Well, there's more than one way to write a vector. So sometimes problems will just give you two coordinates. Let's say if they give you two coordinates, you just mark the 2 points and draw a long arrow to one of them, wherever it says it's heading towards. But sometimes it defines this notation by exploring how far it goes out to the right. This and let's say this could be a decimal, this could be a fraction, and they could give it to you in a weird number. But essentially, depending on the angle, you're supposed to be able to figure out at what point the vector is reaching towards. Now, this method is actually pretty precise, but can only realistically be used if you have a calculator. Now, here's where we get to the main parts you're going to talk about in pre-calculus. It is the concept of adding vectors. So, let's say we have an arrow pointing to the right and an arrow pointing upwards. And the values of these are 20 and 50 respectively. It might be easier if you think of these as forces, but what do you think would happen if these two forces acted on one object at the same time? This kind of ties into physics. Now, if you think about it, well, the object gets pushed 50 units to upwards while it's also getting 50 to the right. So it's getting pushed by 50 and 20. And if you add that up, you can put these two together and find the diagonal. And this C, using the Pythagorean theorem, is what the total vector is, as in the result of the addition between 20 and 50. Let's look at some more different examples. Is the resolution of the stream okay? Seems fine. Alright, now, let's say main point is that you need to you can just put one end of a vector onto the tip of another. So these two vectors would be headed this way and this way. Now, to add these two, you just put them together like you would there, like the arrows here and the arrows here. And now you just draw line from the start of the first one and the arrowhead of the second one. And now you get the answer. And because it's addition, you also don't need to worry about the order in which you add it. Even if you were to go add this first, then go here, the distance is the same. This is regardless if you go no matter what direction you go. So even if you were to switch these two around, they would be the same because it doesn't change the angle and the distance that you're talking about. Now, when you talk about subtraction, however, there's a something different that you need to do. So, what is the negative version of a vector? So, let's say we have a vector that heads towards here. If we negative is just a reverse, right? If we reverse it, we don't in vectors, we don't actually change the number. We only need to change the magnitude, meaning that it heads this amount towards exactly backwards. So you just flip the arrow over by 180 degrees. Now, if you were to apply this, let's say we had two vectors. Let's call this v, and let's call this w. Well, v plus w we know is already this and this, but v minus w. What is the opposite of w? Well, we flip it over here, right? And we add these two together. So it goes here and there. So now this distance is the correct number that you need to calculate for. It might seem weird at first because these angles might seem unnatural or they might not seem instinctually the correct answer. But if you try to logic about it, if you try to use your logic about it, you'll see that it's right. For example, because these angles are almost in perfect opposition at later, when you push them together, they end up at a exact 90-degree angle. Let's look at some problems in which you'll see these types of vectors often. One thing you need to start keeping in mind is that let's go over the different forms in which you might see vectors presented. You might get two coordinates, let's say 1 comma 2 and 3 comma 4, and it's going from 1 to 2 to 3 to 4. So we have it 1 2 and 3 to 4. It's heading towards stairs, so the arrow is on there. Now, that is how you would solve a problem that asks for an arrow using two coordinates. Now, let's say this time we have, sometimes they give you an angle. Let's say 45 degrees and 30 out. This also sort of ties into polar coordinates later on, but polar and vectors are actually pretty closely related in terms of how they're represented. So this would just head out by a distance of 30 going at a 45-degree angle. Now, the final concept that we need to go over in this video is how to multiply vectors. To multiply vectors, you need to apply something called the dot product method. So to do this, you take v times w, and this part's the same as before, but instead of just doing that, you take v times w. And by the way, when you write v without us showing that on top, it means that you're just referring to the number of the vector rather than the direction. So in this case, you multiply the two numbers of the vectors, and then you take multiply it by the cosine of the smallest angle between the angles. As in, if you had two vectors heading this way, you take this angle and not this one, not this one. You take this one. And you call that theta. Now, the reason this works is because when you define the when you take the cosine of the angle between the two, sort of figures out the ratio between the two magnitudes, and it allows you to and it gives you a variation that would like allow you to figure out how much of these are not wasted against each other. Because if you were to push on two forces from other sides, not all forces would end up the same way, right? Because some forces are being pushed together, which means that force would have been wasted. Let's look at some applications of uh real problems where you might see this happen. So most of these word problems will generally tend to be physics problems. Let's say we have we have a plane, right? I am terrible at drawing, excuse me. Right. This plane is heading forward by a magnitude of 50. However, the wind blows it at a magnitude of 70 to the right. What is the magnitude of the plane? So, to do this, you just simply do 50, 70, and make a triangle and figure out the hypotenuse. Next, this one's a bit harder. Sometimes you'll get some kinds of pulley problems. So if you had if you had a circular object and then you had a rope pointing this way, you have a rope pulling this way. How do they work out? In this case, it's the same too. You pull this out here and pull this out here, make a triangle, and the final magnitude is here. And in this case, most cases, they're gonna give this to you in an angle formula. Like this might be 30, well, this might be, say, 20. Essentially, yeah. No. No. Sometimes, and finally, sometimes, especially when you get to later bits of calculus, you'll kind of get a, you'll kind of get a, uh, two numbers, two numbers, except that it's not a specific coordinate. Rather than that, well, the way you treat it is similar to a coordinate. It's just gonna give you two numbers like, say, 20 and 5. And the value of this, when they only give you one thing, but it wants you to find the vector, is that you move to the right by 20, which means that it has a rightwards magnitude of 20 and an upwards magnitude of 5. So you would draw the arrow here. Hmm. In the end, vectors aren't too prevalent whether you go through pre-calculus or even when you look at calculus. You only see it at a couple problems, and even in those cases, all you need to remember is the fact that it has a magnitude. If you try to logic it through, it should not be too hard. And even the tests in pre-calculus don't tend to focus on vectors too often. It's often a topic that is skipped because or not spent more than like a couple classes on because the concept itself is not too important. You're actually gonna see this used a lot more in uh, physics rather than pure math. So in the next class, we're gonna actually move on to another short topic instead of continuing on vectors like we normally do. All right. Have a nice day, everyone.